Today, we're going to talk about a revolution, one that's happening all around us, but on a scale so small, it's almost impossible to wrap your head around. It's a technology that is already changing, well, everything, from the air we breathe to the devices sitting right in our pockets.
So let me ask you this. How in the world can we fight something as massive as global pollution with a tool that's a billion times smaller than a soccer ball? It honestly sounds like something straight out of a sci-fi movie, right? But this isn't fiction. This is the incredible promise of nanotechnology.
So, how do we pull it off? We do it with nanotechnology. You can think of it as the ultimate toolkit. We're not building with bricks or wood anymore. We're building with the very atoms and molecules that make up, well, everything. We're talking about a level of control over the physical world that, not too long ago, was just an idea.
And to really get a feel for how small nano is, check this out. A single strand of your hair, it's like a giant highway compared to this stuff. We are operating in a world where we can actually see and move around individual viruses, or even the double helix of your DNA. This is the playground where nanotechnology works its magic.
Okay, so you've got this incredible power to build things from the atoms up. Where do you even start? Well, how about we start with one of the biggest problems humanity has ever faced? I mean, the problem is just immense. You've got industrial waste, toxic gases, contaminated water. These are massive, complex issues that have been plaguing us for decades. And a lot of the old solutions feel kind of like trying to catch sand with a fishing net. They just aren't precise enough to work.
But here's where nanotech changes the game. See, because these particles are so tiny, they have a massive surface area compared to their size, and that makes them incredibly powerful. They can act like molecular supersponges, just grabbing onto pollutants. Or they can kickstart chemical reactions that break down toxins into harmless stuff. Or they can form these ultrafine filters that catch tiny contaminants that would slip right through anything else.
And we're not talking about a small improvement here. Take dioxins. These things are notoriously nasty, toxic pollutants. Well, it turns out carbon nanotubes are 3 times better at grabbing them than activated carbon, which is a standard filter used in industry. That's not just better, that is a complete game changer.
Now, you might be thinking this all sounds incredibly high-tech, totally man-made. But what if I told you that the greatest nanotechnologist on the planet has been doing this for billions of years?
That's right, nature. When a volcano erupts, it spews out millions of tons of natural nanoparticles. And these particles travel all over the globe, affecting weather patterns, affecting entire ecosystems. It's just a powerful reminder that we didn't really invent something new here. We're just learning to speak a language that the planet has been using all along.
And it's not just volcanoes. It is literally everywhere. You have bacteria and fungi that are constantly making metallic nanoparticles. Plants and algae use them. Even sea spray and forest fires are churning out these tiny little structures. So the big takeaway here is that nanotechnology is a fundamental part of how our world works.
So, if we want to harness this incredible power for ourselves, how do we actually make these nanomaterials? Well, broadly speaking, we've come up with 2 main ways to do it. And the best way to think about them is as a sculptor versus a builder.
On one side, you've got the top-down approach. That's our sculptor. You start with the big block of material, and you just chip, etch, and carve away everything you don't need until only the tiny structure you want is left. Then, on the other side, you have the bottom-up approach. This is our builder, carefully placing each atom or molecule one by one, kind of like Lego bricks, to build something totally new from scratch.
Let's look at our sculptor first. The big plus for this top-down method is speed and scale. It's awesome for mass production. But, just like a real sculptor, it's pretty wasteful. All those little chips and bits that get carved away are just lost material. The whole process can also be a little rough, introducing tiny flaws, and you just don't get that superfine atomic-level control.
And now, the builder. This method, it's elegant. You get unbelievable precision because you're literally building structures atom by atom. That means almost zero wasted material and way fewer mistakes in the final product. The results can be just about perfect. The catch? Well, it's slow, and it's much harder to scale up for mass production. It's kind of the difference between a factory assembly line and a master watchmaker crafting a single piece by hand.
So we've got these incredible ways of making materials with almost magical properties. And while cleaning up pollution is an amazing application, believe me, it's just the tip of the iceberg. The impact of this technology is, well, it's everywhere. Honestly, the scale of this is just mind-blowing. It's not just one field that's being transformed. This is a fundamental shift in how we make things. Medicine, electronics, energy, materials. Nanotechnology is the secret ingredient that's making everything smaller, faster, and way more efficient.
Let's take an example you probably use every single day. The reason we can cram terabytes of data onto a tiny hard drive? Nanotechnology. Engineers are arranging these nanoscale magnetic grains on the disk, packing way more information into the same amount of space. But it goes deeper. We're getting into something called spintronics, where data is stored by the actual spin of an electron. It's like a whole new language for computing.
In medicine, the possibilities are, wow, even more life-changing. Imagine tiny particles that are designed to hunt for cancer cells in your body. They can deliver a powerful dose of medicine straight to a tumor, leaving all the healthy cells alone. Or they can be designed to heat up when you shine a light on them, literally cooking the cancer from the inside out. It's targeted, it's precise, and it's absolutely revolutionary.
And what about energy? Another one of our huge challenges, right? The battery in your phone or in an electric car is limited by the materials inside it. But by restructuring silicon at the nanoscale, scientists have created anodes that can store 10 times more energy than the graphite we use today. This is the key to batteries that last longer, and electric vehicles that can go way farther on a single charge.
So, when you pull all of this together, it becomes pretty clear we're standing on the edge of a brand new era. We're moving away from just finding materials to actually designing them, atom by perfect atom.
Look, if there's one thing to take away from all this, it's simple. Nanotechnology isn't some far-off futuristic dream. It's here, it's real, and it's working right now, solving some of the biggest problems we have in our environment, our health, and our technology.
And that leaves us with a final, really awe-inspiring thought. For the first time in all of human history, we have the power to build our world from its most fundamental building blocks. So the question isn't really, can we do it anymore? The question is, what will we choose to create? The possibilities are truly limitless,